Hokie dokie. In this problem, they say which of the following contains all of the intervals where this graph, or the graph of this, lies below the x-axis. If you are capable of graphing this in Desmos, at least for a quiz situation, then that would be what I would recommend. If you are not, then we'll talk about the super fun long process to go about that. So starting off just by graphing this real quick in Desmos, there are ways of doing it in Excel. If you are able to use Excel, which I'm not sure if you are or not, let me know and I can show you how to graph something like this in Excel. So graphing this function, we are looking for all the intervals where the graph lies below the x-axis. So I'm going to look a little bit closer here. Kind of scale it a little bit differently here. We're looking for all the intervals where it's below the x-axis. So below the x-axis, we're looking at here to here. So here to here, we see it's below the x-axis. So from -2 to 0, the function is below the x-axis. And then it looks like after 8, it is below the x-axis. So from 8 to infinity, I suppose, it is below the x-axis. So again, from -2 to 0, and then 8 to infinity. -2 to 0, and then 8 to infinity, which leads us to E automatically. Okay, now let's talk about the super fun long process that they might expect you to know how to do starting now. All right, first step is factor. Factor this expression as far as you can, starting with pulling out a greatest common factor of -x cubed. I would factor out a -x cubed because that will leave you with the easiest thing to factor, like once you pull out -x cubed. Okay, when we factor out -x cubed from these three terms, we get positive x squared, we get -6x, and then -16. So once we basically divide all those terms by -x cubed, we are left with this. So we have -x cubed as a factor. And now we need to factor this expression into two more smaller factors. So we need two numbers that multiply to -16, but add to -6. So trying factors of 16, I think of 8 and 2 right off the bat. And so how can we modify the signs of 8 and 2 so that they add up to -6? We have -8 and +2. So -8 plus 2 is -6, but -8 times 2 is -16, so that works out. So from these factors, if we're basically looking for where this function crosses from below to above and then above to below the x-axis, we want to use these factors to find the x-intercepts, or the zeros of this function. So we set each of these factors equal to 0. So starting with, I guess, -x cubed equals 0. We solve for x, or we think about the x value that could make -x cubed equal to 0, and that's just 0. And then we set the second factor equal to 0, solve for x, we get 8. And then we set the third factor equal to 0, we solve for x, and we get -2. So this is kind of the idea of, like, if you have x minus 8 and x plus 2, you take the opposites of them basically as your solution. So these are our 3 x-intercepts. So we're already on a roll. Like, we saw those 3 x-intercepts on the graph. Now it's just a matter of looking at the leading term of this function, the term with the highest exponent. That is -x to the 5th. The -x to the 5th, the term with the highest exponent, decides the behavior or the overall, like, path or shape of this curve. And so if you have a negative function, well, let's start with this. If you have x to the 5th, what you have is what's known as an odd function or odd behaviored function. If it's a positive x to the 5th or a positive odd function, the end behavior will look something like this. It'll start lower left and end upper right. So with something like x to the 5th, it may not just do something like this. It might go wow, 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 something like that. But if it's negative x to the 5th or a negative odd function, it's going to look a little more something like this. It's just going to be the flip, really. It's just going to start upper left and then end lower right, and it may do something like this in between. So that is going to be the most helpful thing. And then we'll talk a little bit more about the factors as we graph this here. So let me try to sketch just a rough graph here. So with intercepts at -2, 0, and at 8, I'm going to try to graph this function. So we know that this function is a -x⁵ function, right? So it should start upper left. So it'll start upper left, and it'll hit our first x-intercept at -2, right? And then we know there's also the next intercept at x = 0. The big thing about this is that x = 0 comes from a factor that has been cubed. X cubed means that when we go down and then come back up to the x-axis and hit x = 0, there's going to be a behavior known as a squiggle, or that's how I learned it. I don't even know what you'd call it, but it has this cubic behavior right at 0. So I'm trying to really bring it on home here. If you look right at 0, it'll kind of have this like flat behavior instead of just passing straight through, okay? But it will pass through, okay? If instead of x cubed right here, let's say we had x² = 0. x² = 0 would have still given us an intercept at 0, but if it were squared, it would bounce off of 0 and return downward, okay? But in this case, it has like a little squiggle, and it passes through 0. So now our next intercept, our last intercept, is at x = 8. And so this function will go up somewhere, come back down to x = 8, and then just pass on through with the end behaviors matching exactly what we said they would. So just using this little sketch of a graph, we can still see that this function is below the x-axis from -2 to 0, and then from 8 to infinity. So that's the long version. Again, if you can graph this, I would try everything in your means to just, create a graph of it on a calculator somehow. And if not, that's a little bit of insight on how to do it by hand. I'll do, I think, 2 more examples by hand without a calculator. So feel free to check those out. All right.